We live by the 24-hour clock. It is the bedrock of our modern existence, the unchallenged ruler of time.
But what if that number, that fundamental measure of our day, is nothing more than a temporary illusion?
Across astronomical timescales, a dramatic shift is underway, a prophecy whispered by physicists, the end of the 24-hour day. This isn't science fiction, it's observable celestial mechanics. The Earth is demonstrably slowing down. The culprit is constant, predictable, and utterly relentless: the Moon.
The Moon's gravity creates tidal bulges. As Earth spins, friction between the oceans and the seafloor acts like a tiny planetary break.
This friction steals rotational energy from Earth, and in return, that energy is transferred to the Moon, pushing it infinitesimally farther away. We must be clear, the change is microscopic. It adds mere fractions of a second over a lifetime. You cannot feel this slowing. If the change is invisible to our senses, how do we know it is happening? The evidence lies in history and in precision. We compare observations from the earliest civilizations, their meticulously recorded eclipse timings, with modern calculations. We marry those ancient records with modern atomic clocks. The clocks run perfectly, but the Earth keeps failing to meet the schedule. The mismatch between human time and cosmic reality forced the creation of a desperate measure, the leap second. The leap second isn't a mistake, it's proof.
proof that organizations like the IERS are actively managing a planet that is constantly losing its spin. If that seems abstract, picture yourself pushing a spinning office chair while dragging your foot slightly on the floor. It continues to turn, but inevitably it slows. The gravitational balance demands this trade-off. We lose rotational speed, and the moon gains orbital altitude.
Earth lasts 25 hours.
Day by day, era by era, the cosmic dancers retreat from one another. If the trend holds true, when will the change become undeniable? When do we tear up the 24-hour schedules and adopt the 25-hour day? This is where we must distinguish between science and sensationalism. The change is real, but the timescale is unimaginable. The best-known estimates, including work from the University of Toronto, put the arrival of the 25-hour day at roughly 200 million years from now. In practical terms, this is utterly irrelevant. No human alive, nor any civilization we can comprehend, will ever need to adjust their alarm clock. But the moon is not the only variable. Other forces, subtle and vast, also nudge the planet's rotation. When mass redistributes, such as glacial melt or massive groundwater shifts, the moment of inertia changes, slightly altering the spin. The Earth is not a perfectly rigid spinning top. It's fluid, it bulges, it warps, and every major event leaves a signature on our day length. Could humanity itself, through grand engineering projects, ever create a measurable effect? At high precision, the answer is yes. We forget that the 24-hour solar day already fluctuates. If we measure rotation against distant stars, the sidereal day reveals the subtle complexity of our motion. While these shifting masses provide fascinating data, they're temporary wobbles. The tidal drag remains the overwhelming long-term driver of change.
The 25-hour day is not a sudden cataclysmic event. It is a slow, relentless drift woven into the very fabric of the cosmos.
We are participants in an energy trade agreement between two celestial bodies, a contract signed in gravity and friction. The verdict is unwritten, but the evidence is absolute. The 24-hour day is temporary. The 25-hour day is inevitable. For those who measure history in eons, the question is not if the time will change, but how many millions of years we have left before we are forced to admit that our day is still getting longer.